everybody. Welcome. Super excited to see y'all out here. It's finally nice to be in person after being remote for so long, so this is pretty great. Yeah, we're really excited to be with you guys. We have some really cool info that we want to share with you guys today. We have a really exciting pattern that Armand touched on. We're going to dive in a little bit deeper on deploying resilient applications with Consul Service Mesh and AWS Lambda. So I'm going to set this water down because I only have two hands. So by deploying this pattern, you can essentially make your applications more resilient, things like traffic spikes or other disruptions that happen. So who are we? My name is Eddie Rowe. I am a product education engineer on the Consul team, and my friend here is the Bulgarian bulldog, known as Krastin Krastev. And Krastin and I are both product education engineers on the Consul team. What does that mean? It's kind of like a mix between a dev advocate and a technical writer. Essentially, we are focused on delivering content and creating content for you guys and for other practitioners. And basically reducing as much cognitive load as possible to help deliver that message and deliver that content to make it consumable for everyone. Also joining us today, we have some wonderful TAs. Thank you so much to Mr. Luke here, fantastic author and engineer for Consul. We also have the wonderful Miles Harrison here to help out. And as we have a question session at the end, we'll be able to use them as resources for some deeper questions to tap into those. So thank you both, and feel free to use them for some more questions that you have. All right, so now that you know who we are and what we're going to be covering today, this is essentially how we're going to get there. Okay, we're going to do a component breakdown, piece by piece, of what we're going to build out for you today, so you'll be able to see what we're building, how we get there, so that way we leave little magic and imagination and a lot more like you see how these pieces can work together. Doesn't really matter what level that you're at with Consul or if you've even used Consul before. The intention of this presentation is for anyone to be able to hop in. Also, don't be concerned about memorizing any of these commands at all. This is all in a public-facing tutorial that you can find on our developer website, and we'll also share a link at the end, so you have a short link to get to that if you'd like. Yeah, so this is our objective on how we're going to accomplish that today. The main pattern is basically we're going to show you is a simplified traffic ingress into a multi-platform cloud-managed service mesh using these technologies here. And these technologies include Consul Service Mesh with HCP Consul, EKS, which is AWS's Kubernetes cloud platform, Consul API Gateway for ingress into our service mesh application, and AWS Lambda for our serverless functions. So yeah, now Krastin is going to go ahead and kick things off for us with the first part of this right here. Mr. Krastin.
Thank you, Eddie. Welcome, everybody. Thank you for joining our session. Today, we're going to tell you with Eddie together about how you can leverage the use of Lambda in your Consul clusters environments. And with all set to state and ready, let's begin. Let's start with very, very simple thing. What is service mesh? How many of you are familiar with what service mesh is? Can you raise your hand? Perfect. Perfect. Still, let's give it a very generic definition so that we're all starting from the same point and there's no misunderstandings. What is a service mesh? A service mesh is basically an environment that facilitates communications between your networking calls from application to application. So let's give it a definition. This in front of you is how a classic style of communication between two services happens. What are the challenges here? We're obviously security, routing, and communication. There's nothing standing between the two services and their networking channels. When we want to have a service mesh deployed, the most important building block of the service mesh are arguably the Sidecar Proxies. They are called Sidecar Proxies because they resemble motorcycle sidecars, because they sit to the side of your application and they intercept every single communication that comes through in and out of your applications. In this case, the Sidecar Proxies are containing the Envoy proxy, which you might be familiar with. Consul leverages Envoy as a Sidecar proxy. Envoy is controlling the lower plane, the data plane communication of networking calls between your services. Consul sits on top of Envoy as a control plane, which means the Consul instructs the Envoy data plane proxies on how to handle traffic, whether to allow it or not, and where to route it, depending on the special instructions that it receives. Now, once this is in place in your environment, this gives you incredible flexibility because it doesn't matter where your services are deployed, be it one cloud provider or another, or on-prem. It doesn't matter because the service mesh extends to them. You can also leverage the power of security by implementing service intentions, and these are basically very similar to firewall rules. However, you don't need to worry about expanding what are the actual endpoints of your services and where they are, because all the enforcement is done on Sidecar Proxies, which validates the specific applications based on their purpose. With that in mind, let's step forward, and this is our current state of our demo architecture that we're going to present to you today. For you, especially, we have a Kubernetes cluster deployed. We also have a Consul service mesh deployed, and we have connected it to Consul and HashiCorp Cloud Platform. This is our blank slate, and we're going to deploy something for you here so that you can see live. We're going to deploy the application called HashiCorp, which is an online store for coffee. This is our end state that we would like to get to. You can see that the HashiCorp application consists of a few microservices which communicate between each other. And we're going to go in detail over the actual course of a path of a communication that goes via all the microservices when a transaction is made, just in a little while. But this is our current goal. And now, next, there we go. And now Eddie is going to help us deploy HashiCorp. Eddie is going to launch a standard kubectl apply command for all the little microservices that are part of HashiCorp. We have prepared all the calls for you, so you don't have to wait for us to type. And this deploys each and every single microservice into the Kubernetes cluster, including a little bit of special code there, which you can see the service intentions, so that the services are allowed to communicate between each other. Now,
You want me to go back?
This is a very fast deployment, so it's probably done by now. But again, this is the current state that we would like to get to. But there is a problem right now. And that problem is that our application is inaccessible to the outside world. So in order to let requests come into our cluster, and in order to get customers to open up our application, we're going to leverage Consul API Gateway. Consul API Gateway is a native Kubernetes interaction that serves as an ingress point into your network and gives you very good control and a lot of routing decision-making and a lot of opportunities to shape the traffic in the way going into your environment. That could be HTTP GET modules and methods. That could be path routing, like in this case. You can see that we have set up a /HashiCorp address. And once we get the request to there, it will be rerouted to our app. But more additionally to that, you can also set up, let's say, customer-facing TLS certificates on Consul API Gateway in the easiest way possible with, let's say, VeriSign or Let's Encrypt. Once you get Consul API Gateway set up, you have a very easy, controllable ingress point into your network. And now, we're going to deploy Consul API Gateway for you as well. Eddie is going to launch another deployment. And basically what that does is instructs Kubernetes to get the YAML deployment and deploy API gateway. Now this takes maybe a minute or two. So we're going to use that time to walk you through a sample request going from the outside into our environment. We start at the top left corner, where you can see there's a client request originating from the internet. It hits the Consul API Gateway external endpoint. Now, when that happens, because we have pre-configured the API Gateway for you, the API Gateway reads the request, which in our case it will be /HashiCorp, and it decides that it needs to be routed to our reverse proxy, part of the HashiCorp application, which is an instance of Nginx. And I think that if we take a look now at the deployment, we will see that, yes, it is complete. Now, Eddie is going to run a command to make sure that the service is running correctly. And we're going to...
I lost Wi-Fi.
We're going to wait just for a moment.
I should have listened. I should have listened.
No problem. Basically, what would have happened here was we could have got an actual endpoint where the API gateway is deployed by the actual EKS cluster. I think Eddie reconnected, so
turn it off, turn it back on.
Let's try again.
Hey.
Perfect. That's it. And now, if Eddie copies that address,
oops,
and puts it in his browser, you should be able to see HashiCorp's UI. There we go. With the slight hiccup, we're off to a good start. Good. So we have our entry point, we have our API gateway configured, our application is working. Now what just happened when we actually accessed the HashiCorp's application? Our request got routed to the Nginx instance, which in itself forwards it to our web frontend, which is very simple, nothing fancy there. The web frontend interacts with the public API, which is a backend point. It has two extra functionalities. One is the product API, which controls and has all the data for all the different coffees that you can buy from our shop. And the other one is the payments API. And now, to make sure that not only our front end is working, but also our back end is working, Eddie is going to make a port forward to the product API service. To the public API service. And then he's going to launch a curl command that does a REST API call to perform a transaction, much in the way that a user would do if they make a purchase that gets routed to the front end. Now we can see here that the call is successful. The public API had contacted the payments API, and the call is performed. Now, if we jump back to the presentation. Now, everything is all good and well here, but with autumn approaching, we have Halloween approaching. So what happens when Halloween comes over? There's monsters about. It gets spooky and scary, right? And it doesn't matter if you believe in monsters or not, but there is one very dangerous monster that rears its ugly head every single Halloween, and that is called Black Friday. Black Friday is a feared monster because every time usage base is up and systems get stressed, and our system is no different than many other systems. Unfortunately, we have the nice problem to have too many requests to our payment service, and we cannot process it. So, what do we do? Eddie, what do you think? Is there a solution to that?
I think where there's a will, there's a way. Yeah, sure.
Perfect.
Let's talk about it.
Tell us more.
All right. Thank you, sir. Thank you. Major, awesome job there. That was great. Thanks for kicking us off. So yeah, now that Krastin has stood up this environment for us, and we have this HashiCorp environment, EKS, with API Gateway, I want to show you guys how we can add some resilience for events like Black Friday or for other events that are high traffic spikes. And boop, we're going to do that. So yeah, just to reiterate, this is our environment right here that we have. And we want to essentially we want to show you how to add that resilience by using AWS Lambda. And for those of you who aren't familiar with Lambda, Lambda is a serverless compute service that's in AWS. It is great for certain applications. In this case, our payments application and microservice is a single function application in our architecture here. And so it's a prime candidate for using AWS Lambda to offload some of those responsibilities. So the question becomes, how do we add resilience while maintaining the security and the convenience of the service mesh? And that's using, part of this is we have to do two main things. To get that, we essentially have to configure stuff in Lambda and stuff in Consul. And what we're going to do is show you what those items are and some of the details. So the first bit in AWS Lambda is we're going to deploy a Lambda Registrator. The Lambda Registrator is a unique Lambda service that will essentially look for tags in Lambda that you put on your unique Lambda services, and this is going to automatically register those services and make them available to your Consul environment. This is also something that you can do manually too. You don't have to rely on the registrator. The registrator is something that adds like a nice layer of automation and value there where you don't have to do it repetitively or on a manual basis. So we're going to go ahead and let's go ahead and hop over to VS Code and deploy this now, because the Lambda Registrator takes like about 4 to 5 minutes to deploy. So we'll deploy this now and then come back and talk about the rest of the steps.
Learn?
Yeah, so if you please hop on over to our dev.dot, our developer guide area here. This is the tutorial that's public today. So again, don't worry about memorizing these commands. We're going to pull everything from the tutorial today to show you how to deploy this. So Krastin, if you would please, can you copy this first piece here? And we're going to go ahead and start deploying this, and then we'll go over exactly what the different components do. So if you go down, grab, Terraform Git. Terraform Git is going to, we already have this module that we've pulled down here, but Terraform Git is essentially going to pull down this module to make it available for you to use. And then we're going to run a Terraform apply -- auto approve, or you can do -- auto approve, there you go. Okay, cool. So now let's take a look at what some of this code is actually doing right here while this begins to run. So up at the top, essentially this is pulling like any Terraform module. It's pulling the module down, it's Lambda-based module. It's also, basically it's grabbing this registrator container, this code here, and putting it in your private AWS ECR repository. And this is essentially how it's going to create the Lambda registrators. Once that container is pulled down, the registrator container, then it's going to create a Lambda function from that container. And if you scroll down a little bit more, Mr. Krastin, we also have some other resources in here. These Consul HTTP resources are some HCP-specific resources that help it talk on Consul and keep it secure. And then if you scroll down a little bit more, we have, these are some of the commands where it puts it to the repository. And no need to memorize any of this. These details are all on our docs. So also the module is very detailed as well if you check that out on Terraform, so feel free to check that as well. But for now, while this is deploying, let's go ahead and go on back to the slides, please. And let's talk about the next piece. So after the registrator is there and this piece of automation is set up, we're going to deploy a payments Lambda function. Right now, our HashiCorp's payments function is an EKS-based workload, and so Black Friday's coming, and so we want to make it a Lambda-based workload. So what we have here is our application payments is written in Go, and so we're going to basically deploy it to Lambda. And I want to call out these 3 tags here that are pretty important. These tags, as we deploy them through Terraform for this function right here, these are essentially what enable the registrator to pick up these different functions in Lambda that you specify. All right, so that is essentially the Lambda configuration that needs to happen right there, the registrator and making your own Lambda functions that are put up there. But that leaves, how does the Lambda-based workloads and the EKS workloads, how do those two talk back and forth? And there's 2 things that we need to do in Consul. The first thing that we need to do is we need to deploy and configure a terminating gateway. And a terminating gateway in Consul is essentially what enables a lot of the multi-platform functionality and features. Like this is something that will sit in between EKS and Lambda in this environment. Okay, it's basically like enabling to any external service. In this case, even though it's still within AWS, it's considered a external service for Consul Service Mesh and the other applications that you have in there. All right, so once this is set up, we're then going to tell HashiCorp to direct the traffic. How do we tell it to direct the traffic? That's when we get into service splitters. So since the public API is the microservice that talks over to the payments service in this microservice example, a service splitter is the component that's going to tell the public API whenever it addresses payments, hey, where do I go? And out of the bat, since we had this spun up initially, 100% of the traffic goes to the EKS-based workload. But we want to send all of that to the payments-based workload in Lambda, or the Lambda-based workload, payments instead of the EKS-based workload. And so with a service splitter, you can choose the ratio there. It can be 75, 25, 50, 50. It doesn't matter what ratio, but for this case, we want to show you 100% of traffic. So we're going to turn on the pipe 100% and send all that traffic over to the Lambda-based workload. Okay, so before we hop back into Visual Studio Code, the 4 pieces. The 2 in Lambda, we deploy a Lambda Registrator, we deploy a Lambda function, we configure, and then the 2 pieces in Consul are configuring the terminating gateway and then configuring a service splitter. All right, it is demo time. So let's hop on over to our developer guide.
Oh, we're still deploying.
Still deploying. Well, it's okay. We can go to our developer guide and we can populate the service.
The second file.
Yeah, the second file. So since the registrator is doing its thing, we're going to deploy this service. So this is our handy dandy Terraform code for our payment service. So let's go ahead and put that in here. Wow, look at that convenient timing. That's just beautiful. Okay, great. So yeah, go ahead and run a Terraform apply auto approve. And let's take a look at this file real quick. If you go up to the top of this file, you'll see this is essentially like a standard deployment for Terraform for an AWS Lambda function. Down at the bottom, there's some IAM kind of policy necessities there to give it capabilities for CloudWatch logs in AWS. Okay, so this is going to deploy here. If you scroll back up a little bit, Krastin, up to the top, I want to show those tags. Like we talked about briefly in the slides, these are those tags that enable the registrator to basically register and deregister this function. Okay, cool. So we've deployed the payments app. The next piece that we're going to do is in Consul. So let's go ahead and hop back over to the tutorial. And scroll on down a little bit. And let's get into some terminating gateway stuff. right. Okay, good, perfect. All right, so with the Terminating Gateway, a note on it in this situation is HCP Consul is secure by default. So that means ACL engine is enabled, MTLS, gossip encryption. When the ACL engine is enabled, there are some ACL policy things that we have to do for the Terminating Gateway in order for the Terminating Gateway to speak with the Lambda service. So we're using this basically a least permissive kind of principle. We want the least permissions possible for this to set this up. So we're first going to set the token here to an environment variable. Awesome. And then let's hop back over there and grab, so let's take a look at this policy first. You can basically just see that the two privileges that are allowed here for these services to speak with each other. And we have this policy pre-rendered. It's in the Terraform that's already there. So we're going to go ahead and copy this code and paste it in. And so now we have a token and we have a policy. The last thing that we need to do over in the tutorial is we need to go down and we need to update this token and basically attach the policy to the token. All right, nice. Okay, cool. Let's hop on back over to the tutorial. All right. And so the next piece, now that we have the ACL stuff that's done out of the way, is we're going to link the Lambda-based service to the terminal gateway right here. And what this is going to do is this is essentially going to allow communication between the Terminating Gateway and the Lambda service. Nice, nice, nice. Okay, let's hop on back over to the tutorial and move on down. Keep on going past that. All right. So we have the Terminating Gateway set up. We have those two things in Lambda set up. Now we're going to set up the service splitter. And so the first part of the service splitter is we're going to set up intentions, like Krastin was talking about. They're kind of like firewall rules for your service mesh. And so we're going to do that in between the public API and the Lambda service. So that allows these two to communicate with each other. So that's also pre-rendered in our demo module here in the Terraform code. So we're going to go ahead and create that. All right. And so that created the service intentions. Now let's create the service splitter policy. This policy right here, like I said before, you can choose any ratio that you want, 50-50, however much you want to go between Lambda and your EKS-based workload. But we're going to create 100% of the traffic to go towards the Lambda-based workload. So this is what a service splitter configuration file looks like. Let's go ahead and apply this. Excellent. So theoretically, at this point, everything is working great. But it's a demo, so let's check it out and see if it's actually happening. OK, so we're going to do exactly what Krastin did before. Let's go ahead and forward the port and make it available for us to communicate with on the public API. And we're going to send a curl on that second terminal. So if you hop on back, grab that curl command, we're going to do exactly what we did before. And this time, we should expect a different result. We should expect it to not say encryption disabled, but to pull up with the result saying encryption enabled and that a Lambda-based thing was returned. So go ahead and run this. And there it is. There's application level verification saying that Lambda is running this service right here. But we don't trust our application 100%. We want to verify. So let's check out in the AWS logs to make sure that this is working appropriately. So let's hop on over here, back to our, skip that, there we go. And so we're going to look on our AWS logs directly and check to see that that Lambda based payment service is the one that's serving this application in the microservice application. And there it is. We are seeing that in the AWS log as well. So yeah, happy days. That's fantastic. Great. So let's. I also want to hop over to the Consul UI, and let's go ahead and see what some of these things look like in the UI, because sometimes it's nice to tie some of these ideas together with the UI and CLI. The first thing, Mr. Krastin, can you click on Terminating Gateway? So you'll see the Terminating Gateway has one linked service, and this is what we did in the CLI. We linked the payments Lambda service to the Terminating Gateway so that these are able to communicate back and forth with each other. All right, go ahead and hop back to the main page. Let's scroll on down, excuse me, to the payment service. And click on routing here. Awesome. What you'll see is you'll see the splitter that we set up with the name of payments in the middle area. And then over on the right side here, you'll see the two services, essentially. The one up at the top, payments, that is the EKS-based workload. And the one below is the Lambda-based payments workload. And so we have 100% of our traffic going to the Lambda-based workload. So that's what some of these changes look like in the UI. Mr. Krastin, can you roll on back to the slides? Awesome. Let's hit the next one. Oh, I can do it now. Forgot. Okay. All right. Yeah. So let's do a quick recap because we kind of blazed through that. When Krastin stood up the environment, this is what we had. We had the HashiCorp's demo application up here with the Consul API gateway for ingress, and this was all working just fine. And this is a great workload. Like, this works for the majority of time right here. Like, you don't need to worry about this. It can handle all the traffic. But Black Friday and other traffic spike events or company requirements for additional resilience or a certain amount of nines can lead to desiring an application architecture like this that adds more layers of resilience for your application. So Lambda, we eventually spun up these services. We performed those 4 higher level steps right there, and we got to this working right here in this environment. The bigger pattern here, like that was the pattern for Lambda, but the bigger pattern here that I want to touch on is, like, while this is a completely silly architecture and we would never really split up our demo application that way, it probably cost a lot more than it really needs to, amongst other things. But the point that I'm trying to make is that it doesn't really matter what platform or runtime you're running your microservices on. It could be ECS, Lambda, on-premise, whatever. It really doesn't matter as long as you build it in such a way that the resilience makes sense and it works for you. The multi-platform Consul is essentially what enables this multi-platform and can run on all these different runtimes. All right, and I'm gonna pass it off to the very end here to Mr. Krastin to take us away. Nice work.
Thank you, Eddie.
Thank you. Oh, yeah, he probably did.
All right. Now, before we jump towards the questions, let's do a very quick recap. Eddie guided you through the beginning of this presentation. This is the pieces of technology that we used to accomplish our goal. Clearly, we used HTTP Consul. We demonstrated the secure by design property of Consul. We used EKS in Kubernetes for deploying our workloads, which was HashiCorp's. We used the Consul API gateway as an ingress point that is flexible and can be controlled. You can deploy other applications in the same environment as well. And later on, Eddie showed us how awesome it is to use AWS Lambda so that you can much more easily scale your workloads and your calls whenever you need to and whenever the need arises. We have our colleagues here, our assistants, our teaching assistants for your questions. And if you guys have any questions, they're all ready to answer them right now. And
yeah, let's open it up.
Yeah, it's
Does anyone have any questions?
So, if you.
Yes, sir. Oh, yeah, can you switch to the next slide, Krastin, so he can copy down the short link?
Right, so you can find the labs on the second short link there.
Sure thing.
Please go ahead, run them by yourselves, test it out. If you have any questions after this presentation, you can always find us at the Consul booth in the zone. Feel free. And yes, I think, any more questions?
Cool. Yeah. Feel free to hang out with us afterwards. But we got one here.
No.
Oh. Oh, whoa. We shouldn't stand too close to each other. No. Okay. So, yeah, no, absolutely. Yeah, the Lambda Registrator is essentially like an automated function that looks for your Lambda-based functions. So if you have services there, it's going to look for these specific tags that you have in your services, and it's going to automatically register those services with your main grouping service. In this case, we use something called payments. So it's going to basically continuously look for additional Lambda services with those tags and register them to your service mesh so that they're available for communication.
URL or something.
Sorry, can you say that one more time?
So your service doesn't need to look for a specific URL for the Lambda or ARN for the Lambda. It will be registered automatically.
Correct.
Okay,
It would just be your main service name, and then it's up to you with the service splitter how you'd like to direct that. That could go to your EKS-based workloads. That could go to a different type of workload, or it could go to your Lambda-based workloads.
And Registrator will work with different type like Lambda, EKS, or whatever. Not EKS, sorry. ECS or Lambda, or just looking for Lambda instances?
This registrator is built just for AWS Lambda.
Okay. Thank you.
Sure, thank you. ECS is supported as well? ECS is supported as well.
Can we get the mic to Luke? Yes.
So ECS is also supported, but it doesn't use the same registration mechanism. So ECS, you can actually run a sidecar proxy alongside all your tasks. And so that is part of the service mesh that way versus Lambda. It's like you can't run a proxy in it. Well, you can, but it's a little bit harder. And so that's why there's a different registration mechanism for Lambda.
Thanks, Luke.
You have a question over there?
Oh.
So are the services that you register like Lambda, is it region bound? So let's say my EKS is in US East 1 in AWS. Can my Lambda be US West 2? Or can I split it to both US East 1 and US West 2 for, DR, for example?
I think that gets into like some multi-cluster, multi-region aspect, right? Like,
I don't actually know the question. Can you invoke a Lambda from a different region? Because basically what's happening is the Terminating Gateway is basically just like invoking the Lambda. But it's handled like transparently for you. So it seems like you're just calling a URL, but behind the scenes, it's actually just invoking the Lambda. So can you invoke a Lambda across regions? You don't know. I will get back to you on that. We can look it up together. Maybe somebody who knows here. Yes, you can. Then yeah, it would work.
cool.
Thanks, Lambda expert over there.
Thank you. Great question. Yes, sir.
So you showed an example of calling from the mesh into a Lambda function, but let's say I'm migrating something from the mesh into the Lambda for resiliency, and it needs to call some other function in the mesh. How do I discover those services? And because I don't think I can run the Consul DNS on in the Lambda instance.
Oh, I see. Is that something that the Lambda Registrator provides? Okay, thanks, Luke. Luke, do you want to come up here and?
Yeah.
That's a great question. So that's what was announced in beta in the keynote this morning, which was like the Lambda to mesh use case. So yes, the answer is yes, we can do that. It's in beta right now. And basically the way it works is it runs like a super light sidecar proxy inside your Lambda using like a Lambda extension. And then that basically just takes the request and then it will route it to like a gateway, which will get you into the service mesh. So now we have like the full capability out of your mesh into Lambda, and then from Lambda back into your mesh. To answer your question there, it's a little bit like if you use Kubernetes, then basically you can use kubedns URLs and like you don't even notice that there's a service mesh involved. But when you're using like the Lambda, you do need to like redirect. You have to direct your request to like localhost and then a specific port. So you kind of need to be a little bit more service mesh aware. But hopefully, like you're using config files or whatever your app is using to like know which URLs to call. So hopefully that's not as much of a problem. Any other questions?
I gotta keep that mic.
Oh, got two.
Thank you.
Come on.
On your last slide, when you had your services split into multi-cloud, some services were running on GKE, some were on AWS. Do you have all counts on each of the cloud providers, or one is?
So yeah, this was like a theoretical slide, but yeah, essentially you'd have so HCP console would still be the like main control plane for this, but then you'd have kind of like we had in EKS, we'd have these console clients on each of the different Kubernetes nodes, and those would be able to essentially pull things into the mesh. So as long as these are able to communicate with each other, via I guess in this case would it be federation?
Yeah. So yeah, console runs on every cloud, and then you can run it on-prem as well. And then like HCP console, which is like the hosted console, that's only supported right now on Amazon and Azure. But if you needed to run it on a cloud that wasn't supported by that, you could run it yourself. It's just not like a SaaS console version. It's kind of like run console yourself.
Do you have a sample for this?
Yeah, there's lots on learn.hashicorp.com. There's a ton of tutorials about running console in different like data centers and different clouds and stuff.
All connected to each other?
Yeah, so you can basically what you do is you connect them using mesh gateways, which is basically like an egress point, because like you can't, like a pod IP in GKE is not routable to like a pod IP in like Amazon, right? So you need like a gateway basically that lets you jump between the two. So you set up two console data centers and you peer them, and then you have this gateway that lets you jump in between the two. Yeah, there's a talk I gave at HashiConf EU called Multi-Runtime Console across clouds and stuff like that, which covers that as well if you just feel like YouTube that.
Super. Thank you so much.
Thank you. Yeah, you and Eric's talk, right, that you had on it.
Yeah, we did a talk with like, we had Nomad running on Azure, and we had like EKS running in Amazon, and we had something running in GKE, like a VM in GKE, and we had ECS running in Amazon, and they're all kind of peered together and communicating.
Any more questions? If you think of some later, feel free to come by the booth. All of our tutorial pages have feedback pages, feedback sections on there too. So if you find anything in the tutorial that's funny or have feedback on, feel free to add something there as well.